wet the solid surface if the angle of contact is. So we are seeing here these are the two different cases. In this, the liquid surface, or we tell it as meniscus, is concave, and here it is convex. Now there are two types of forces, which is cohesion and second one is adhesion. So this cohesion force is basically, in this case, it is in between water and water molecules. The adhesion is, or not water, liquid and liquid, because in the second case we are taking mercury, and the adhesion is between liquid and solid. So if we see here, in the first case, what is happening is, why it is concave? So these water particles, they are pulled, by the glass particle. So there is a force of adhesion here, and since the force of adhesion dominates the force of cohesion, cohesion is the force Q, which is the force of attraction between water and water molecules. So adhesion is dominating here. Okay, so that's why here it is concave. Okay, because if you see, the surface is actually pulled towards the solid side. In the second case, in the case of mercury, the mercury droplet is having more of cohesion force than adhesion. So you can see the vector force of adhesion is very less here, adhesion. The vector force of cohesion is very much here, more here. Here adhesion is dominating over cohesion. So in this case, this R, the resultant vector, is towards the liquid side. So therefore here it is convex surface. Okay, so now we can figure it out that the liquid does not wet the solid surface. When it will not wet the solid surface? So actually I remember once in our lab we were there, and there was an experiment of mercury. And the mercury, when it is spilled over on the table surface, there are no droplets. Okay, you can very well, you can spill it and then again collect it, and not even a single small droplet also was there. Okay, which is not the case with water. Water, it makes the surface wet. Okay, so the entire mercury was, like you can flow it and then you can collect it, and as much as you flow, that much you can collect also. Not even a single drop is remaining outside, or it sticks to the solid surface. So when does this happen? This happens when the force of cohesion is more than the force of adhesion. Okay, so in this case, okay, and obviously cohesion, so liquid does not wet the solid surface. It will wet the solid surface when solid surface attracts it more. It will not wet if it attracts less, and therefore the case will be the second one. Okay, and now let us see the contact angle here. So if you see the contact angle, okay, so how to draw the contact angle, how to understand the contact angle? So draw the tangent to the surface. So this is the tangent, and then the angle, okay, this is known as the contact angle. This is theta here, this is the theta contact angle. Here in this case, draw the tangent and along with the other surface, so this is the contact angle. Okay, So in this case we can clearly see that the contact angle is greater than 90 degree. It's obtuse. Okay, so that's why the option is going to be C. Thank you.